Have you ever just stared at a huge problem and your brain just freezes? You have no idea where to even begin? Well, today we're going to unpack a mindset that can totally change that. It's called computational thinking. And no, it's not about turning into a robot. It's about learning to solve problems the way a programmer does. And trust me, it's a skill that's useful for, well, pretty much everyone. So let's dive in. Okay, let's just jump right in with a big one. Think about a ride-sharing app. Like an Uber. You've got live maps, tons of drivers, even more riders, payments, ratings. It's this massive tangled web of stuff all working together. Seriously, how would you even begin to build something like that from scratch? It feels impossible, doesn't it? Well, that's exactly the puzzle we're going to start picking apart today.
And the key to solving that puzzle is right here. It's this thing called computational thinking. This is the mental toolkit you need to take a huge, scary challenge like that and break it down into something that's logical, that can grow, and this is the best part, that's actually solvable.
So you're probably wondering, how do we actually do this? Well, here's the game plan for today. We're going to start by learning how to simplify and break down a problem. Then we'll get into finding patterns and creating a step-by-step plan. After that, we'll put it all together and see how it cracks that Uber puzzle. And finally, we'll zoom out and see how this way of thinking is a total game changer for problems way outside the world of coding.
All right, first things first. When you're staring at a mountain of a problem, the #1 rule is don't try to climb the whole thing in one go. You just can't. The real key is to simplify it, to break it down into smaller, more manageable chunks. That's the only way you can actually start building a real solution. So our first tool in the toolbox is something called abstraction. And honestly, you can think of it like a superpower. It's the power to cut through all the noise and focus only on what truly matters. It's pretty much the foundation for simplifying any big challenge.
I love this idea that abstraction is basically intentional ignorance. Yeah, you heard that right. It's about making a conscious choice to ignore all the little details that just don't matter right now. When you strip all that complexity away, suddenly the real problem you need to solve comes into sharp focus.
And here's the thing, you do this all the time without even realizing it. Think about driving a car. You're focused on the steering wheel, the pedals, the mirrors, right? You're not thinking about the thousands of tiny explosions happening inside the engine every minute. All that complex stuff is abstracted away. Or let's say you were building a system for a library. You'd focus on books and members, not the kind of bricks used in the building's walls. See? You're ignoring the irrelevant details.
Okay, so abstraction helps us filter out the noise. Great. But now we're left with this core problem. We still need a tool to actually break that problem into smaller pieces. And that's where our next tool comes in. It's called decomposition. So if abstraction is all about seeing the forest instead of every single leaf, decomposition is about taking that forest and dividing it into individual trees. It's how you take one massive challenge and just slice it up into smaller, bite-sized tasks that you can actually tackle one by one. Think about planning a party. You don't just have one thing on your to-do list that says plan party. No way. You break it down, right? You decompose it. You have book a venue, send out invitations, figure out the catering. Each one is a separate, manageable task. And it's the exact same thing in the tech world. If you're building a calculator app, you break it down into building the user interface, handling the button clicks, writing the math logic. You get the idea.
Okay, so quick recap. We've simplified the problem and we've broken it into pieces. Now the fun part begins. We get to shift gears from just understanding the problem to actually building the solution. And this is where we get smart and start looking for efficiencies.
And that leads us right to our third tool, pattern recognition. Now this is the secret sauce. This is the mental superpower that keeps us from solving the same problem over and over and over again. The real magic of pattern recognition is spotting these repeating structures. You start to see that different little pieces of your big problem actually look kind of the same. And when that happens, you don't have to invent a new solution for each one. You can create one solution and just reuse it. It's a massive, massive time saver.
Yeah, this quote really nails it. So often, we think we're juggling 10 totally different problems, but if you really look closely, you might find you're just solving one core problem that just happens to show up in 10 slightly different ways. Finding that common thread, that's the key. All right, so we've simplified, we've broken it down, and we've found our patterns. We're so close. The last piece of the puzzle is creating a super precise plan of action. And this brings us to our fourth and final tool, algorithmic design.
Now, I know the word algorithm can sound kind of scary and technical, but don't let it fool you. All it is a recipe. Seriously, it's just a step-by-step set of instructions to get something done. The only catch is that the instructions have to be crystal clear, zero ambiguity. So clear that even a computer, which takes everything literally, can follow them without getting confused.
I mean, just think about making a cup of tea. That's an algorithm. You boil water, you add the tea, you add sugar, and so on. It's a clear set of steps in a specific order to get a predictable result every time. That's it. That's all an algorithm is. It's just the recipe for solving one of those smaller problems we broke down earlier. Okay, get ready because this is the aha moment. We're about to bring everything full circle. Remember that massive, impossible problem from the beginning? Building that ride-sharing app? Well, we're going back to it. And we're going to use our 4 new tools to sketch out a blueprint. And watch how this all just clicks into place. First up, abstraction. We ignore everything else and just focus on the essentials. Pickups, drop-offs, maps, drivers, and payments. Simple. Next, decomposition. We break the whole app into smaller chunks. A login module, a booking module, a map module, a payment module. See? Manageable pieces. Then pattern recognition kicks in. We realize, hey, the basic logic for requesting a ride is pretty much the same for every single user. The process for assigning a driver repeats over and over. And finally, algorithmic design. This is where we write the actual recipes, the step-by-step instructions for calculating the route distance, for matching a rider with the nearest driver, and for figuring out the fare. And just like that, our impossible problem suddenly has a clear, logical structure. It's not so scary anymore, is it? So yeah, we just sketched out how to build a complex app. But the real power here, the big takeaway, is that this mindset has nothing to do with just being a coder. This is a framework for thinking that you can apply to, well, pretty much anything. So why should you care about this if you're not a programmer? Because it's not about the code. It's about training your brain to be a better analytical thinker, to approach challenges in a more structured way. This levels up your problem-solving game across the board. It helps you make smarter decisions at work, in your studies, heck, even in your day-to-day life. And it all comes back to these 4 powerful tools: abstraction, decomposition, pattern recognition, and algorithmic design. 4 steps that, when you put them together, give you a system for tackling almost any challenge that comes your way. So if there's one thing to remember from all this, it's that computational thinking is not about thinking like a machine. Not at all. It's a structured, human way to solve messy, human problems more effectively. Whether you're trying to launch a business, write a research paper, or even just figure out the best way to renovate your kitchen. Look, this isn't just some abstract theory. You now have a powerful new mental model, a new lens for looking at the world. So I'm going to leave you with a question to chew on. What big, intimidating problem in your life suddenly looks a little bit more solvable now?